Hello everyone, my name is Mickey and we are going to understand binary search in detail inside this video. We are given with a vector, where we are passed with a target value in order to search that target inside this array, or you can call it as vector. Vector is dynamic array, a kind of array, but it is dynamic in nature. So we are given with a target value which we need to search inside this array, and we are taking two parameters more inside this function, which is start and end value. In order to search the target value inside this vector, we need to pass the start as well as the end to this binary search function. Next, what is the stopping condition? Because it is using recursion, the base case here lies is whenever the start value, the start value and the end value becomes equal, in that case we need to stop the recursion, and it continues until and unless when the start value is less than end value. It continues, recursion continues, and it recursively searches for this target inside this vector. In order to understand binary search, first we need to calculate the mid value, and based on the mid calculation we need to compare that mid value element every time with the target value. Every time you compare the mid value element, mid index, which you get from here by calculating start plus n minus start divided by 2, which will give you the mid index of the given vector. Every time you get the mid value, recursively you calculate the mid value. Every time for the new element you get, you compare it with the target value, and every time if the comparison matches, then if you return the mid index from there. If it doesn't get the mid value inside this index is not equal to this target value, then you need to do this two steps ahead in order to get nearer to the target, which is if the mid value is less than equal to the target, then you need to call the binary search recursively again, but now the parameter is being changed. The array remains the same because we are not changing the array, and the target also remains the same. But the case here is if the target is less than equal to mid, it cannot be found in the left side of the array, because the mid value which you are getting is less than the target. So once you perform binary search, you need to understand that binary search can only be performed on sorted array, and when you are trying to perform elements or comparing elements which is less than target, any index which you are getting as a mid and you are comparing with the target value, if it is becoming less or equal, then you cannot be found on the left side of the array. If this is the array and you're getting mid 7 and target value is suppose 9, you cannot get 9 and the left side of this array, so you are completely discarding this left side and you are trying to search after 7. After 7 you can get 9. That is the case when you are getting array where the mid value is pointing at the element is less than the target. Now what you have to do is you can recursively call binary search, and you can pass the array as well as the target. Now you have to pass the mid value or the starting value as mid plus 1, because you can see if you are searching for 7 and the mid value is you're searching for 9 and the mid value is 7 here, then you need to pass all those array elements which are after mid. If 7 is the mid, then after mid elements would be 8 and 9. So you need to compare only those elements and you need to discard this left side elements. Then what you get is these two arrays. These two array elements will be left out for searching. So our searching will be way more faster than linear search. This is the parameter that you are passing to the recursive binary search again in order to calculate the target value. So mid plus 1 and end. Next comparison remains is 8 and 9. If the mid value is becoming greater than or equal to the target, if the mid value is greater than or equal to the target, then you are not able to search on the right side, because every element that you get on the right side is always will be always greater than the target. Now we need to search on the left side. If you are suppose you are on 7 and you need to search for 1, you cannot get 1 on the right side of the array because the array is sorted always. So you need to search on the left side and completely discard the right side elements. In this case you need need to call binary search recursively again if the array element which is present at the mid index is greater than or equal to the target by passing the parameter. Start remains the same because we are not changing the start here, and we are only changing the end value where end was pointing here and start was pointing here initially. So you are not changing the start pointer, but you are changing the end pointer here, and you are moving the end pointer from here where the mid was pointing to mid minus 1. This becomes a new end. This is how binary search calculates the target every time, and if it is found from this point, it will return the valid index. If it is not found, it will return an invalid index, which is -1 if the target is not found by entirely searching in this array using binary search. So this is how we calculate binary search. See you in the next video. Like and share for more.